All right. So you can choose what we can do today or in what order. We can talk about the exam. We can talk about the probability. There are two questions that I asked before the exam, or we can continue with all the time complexity topic. And so what do you guys want to do? And in what order? I'm asking about the permutation versus combination thing. Hmm? Talk about the exam? Okay, we can do that. All right, so let's talk about the exam. And I do apologize for all the clerical mistakes that I made. So that is, I kept tweaking the questions until the last moment, and I just didn't get enough time to check everything. All right, so this is the exam, just in an HTML format instead of in PDF. So I just thought, we can look at it this way. I chose the ID 0, doesn't really matter which one. And then the key, I can also show the key side by side. I think there's enough room to do it side by side. So the key is the same name, except it has a K for key. And we can pull this into its own window. Okay, there we go. And then resize that so that it is side by side. Okay. And then resize this one too. So they are truly side by side. We are not missing anything. I think it needs to be a little shorter, like that. All right, so that's that. This one also needs to be a little bit shorter. All right, so on the right-hand side, we have the key or the answers. And then on the left-hand side, we have the actual question. It took me this morning to kind of generate the keys. All right, so let's go to question number 1. So question number 1 is asking about the aleph null module, function G. And I apologize that this is probably throwing some people off here because we never talked about the proper name of the G function. It's called the Cantor pairing function. That's the official name. I have been teaching this particular function for a while, not knowing that somebody else discovered the same function, and that person was Cantor. I talked to Phil Smith, one of the math professors along the hallway about Cantor's pairing function, and one comment from Phil was Cantor went mad at the very end of his life. So I haven't really read about his wiki page or Wikipedia page yet, but I heard it is quite interesting. Anyway, so that's the pairing function. It can be applied to convert an array of finite number of elements to a single unsigned integer, and it is null terminated. So this is the function. It is defined recursively. So this is the h function. It can potentially call itself, and this is a ternary expression, which basically means if x bracket 0 equals to 0, which means we found the null terminator, then it just returns 0. However, if x bracket 0 is not a null terminator, then it will call g, which is the Cantor pairing function, which is the same as the g function that we talk about in the aleph null module. And it would use the first element of x as the first element or the first value in calling g. And then the second one is h of the rest of the string. So I particularly did not use a pointer because I thought using pointer arithmetic, which would be x plus 1, instead of this expression here, it would have been x plus 1, and that is actually more confusing than the address of the second element of the array. So I hope that helps a little bit instead of just x plus 1, because in terms of pointer arithmetic, that means exactly the same thing. So essentially, it means the rest of the string, okay? Because every string in C++ is an array of characters. So when you move the pointer to the next one, it is basically you're looking at a substring of the original string with the first element, not being a part of it. Okay. So in this particular example, the zero terminator is added. So everything that I edited, during the exam is also noted here. So this way, we kind of know which part is modified, in the exam. So in this case, the array has 5, 6, and the no terminator here. And I'm trying to determine what h of r, ARR, is going to return. So this is the answer. The answer is not in C++ format, just because in JavaScript it is a little bit easier to read. So we are looking at the h value of 560 as an array because it's no terminated. After the first call, because 5 is not 0, so it will separate out the 5 to become the first argument of calling G, and then the rest is going to be h of 60, which is the remainder of the entire string. So that would cause the first recursive call. The first recursive call will basically look at this. Oh, okay, I forgot about this. So this is supposed to be the 6. Okay, I forgot to put a dollar and then curly brace around it. So this is 6, and then it will try to find out what is h of, this time the null terminator. And then in the very end, but this is the bottom line. Okay, the bottom line is it will be g of 5, comma, g of 6, comma, 0, close paren, close paren, which in this case turns out to be 372. So I'm just going to pause here, with part 1. How was it? Did you guys were you guys able to figure out how to track down the recursive call? Okay, some people nod. Okay, so how did you do it? Okay, I just want to figure out how, for the people who figured it out, how did you figure out how to follow the recursive call? If you want to share. Yeah. Mm-hmm. Yep. Yep. Okay. And I think the key is to understand what this notation is, okay? The address of the second element of the array, okay? And that part is, kind of, it traces back to CISP 360, really. But 400 and 430 probably have used notations like that as well. Yep. Mm-hmm. Mm-hmm. Until x bracket 0 is 0 in that particular invocation, then it stops all the recursion. That's the end of the recursive call. Because if x bracket 0 is 0, it means we have found the null terminator. And then at that point, it just returns a 0. And then we just kind of back up the whole thing. Exactly. Yep. Yep. I forgot to specify the null terminator when we do the initialized array. And was this notation introduced in C++? How to create an array that is initialized. Okay, very good. All right, so that's part 1. If somebody give me, basically the last form here, but without a calculator, so that that person cannot do the actual calculation quickly, that will be worth like most of the points already. In other words, if you did not have a calculator and you finish it up to this point here, you'll get like most of the points, like 3 out of 4 at least. Okay. All right, so part 2. So the good thing is part 2 does not really depend on part 1, okay? Not in the traditional sense. Let T be the set of all finite length null terminated strings of char. Then H can be seen as a function because it is basically converting each element in T, meaning a null terminated string of chars, into a natural number. So is that part okay? Does everybody understand what this statement, let T be the set of all finite length null terminated strings of chars? Okay, because that statement is super important. I'm not just saying that it is a finite length no terminated array of any kind. It is specifically of a char. And I think the question also said a char for all practical purposes in this question is unsigned. Now in reality, char is actually signed, which doesn't really make a lot of sense, okay? Because a char is a 8-bit number that is storing the ASCII code of a character. Okay, there's no reason why it should be signed. Yes. I am recording. Yes. Mm-hmm. So, but that is important, okay? Because that means when you apply the inverse of G, you should be getting something within the range of 0 to 255 for the first element of the two tuple. When you apply G inverse. Now the other element of the two tuple can be a large value because that by itself can be containing a substring or representing a substring. So function H is not a bijection, okay? So that means it is missing at least one of the two requirements to be a bijection. So it's either missing injection or it is missing surjection. You don't even have to figure that part out because I'm telling you, H is an injection, but not a surjection. So that means no two strings will map to the same natural number, but not every natural number corresponds to a no terminated string. Okay, that's basically what not being a surjection means. Okay, because not all the natural numbers are used up. So why is H not a surjection? So I want you to explain to me why it is not. But there's a hint. Okay, argue that H cannot return a value of blah blah. Okay, this number may not be the same for you, but the approach would be the same. In other words, no terminated string of 8-bit char as parameter x. Parameter x is referencing the parameter of how H is defined, can return this value. Show your work and logical steps. All right, so the key to do this is to basically go like, okay, so if this number, okay, let's just call that V, okay? If V is the actual result of applying H to a no terminated string of chars, then I should at least be able to do an inverse like this and then figure out what is the first character of the string, okay, by applying the inverse. But if you apply the inverse of G, you will figure out that the first item of the inverse is 380, which is greater than 255. Now, your specific question may not match this one, okay, because I just use a whole bunch of numbers that are greater than 255. So yours may be a little bit different, but it is still greater than 255, which is now telling us, oh, okay, there's no way an 8-bit character can be representing 380, signed or otherwise. So that's how we can prove that, okay, it is not surjective. Is that proof okay? It is. It's a counterexample. Okay, we are not proving that it is. We are proving that it is not surjective, which makes it a little bit easier. Yep. Mm-hmm.
But wouldn't it also be not injective because it returns an unsigned int? Like H returns unsigned. So if well, I guess maybe the upper bound you run out of. Okay, I'm trying to figure out.
It is injective because if you give me two different no terminated strings, it is guaranteed to return two different natural numbers. That's how it is.
If you have a really long string and the number gets really, really big,
Uh-huh.
the unsigned is going to have a ministry overflow and it's going to end up mapping back to a number that's already mapped. Right?
So you're taking into consideration of the finite width of an integer. Yeah, if you take that into consideration from a programming perspective, everything is going to be non-inject. Well, not everything, but in this case, it is not injective because it would just wrap around. Mm-hmm. So if you present that argument, then I would take part two and go like, okay, fine, you did your analysis, okay. But assuming that we are talking about integer or unsigned integer as a natural number, which means there's no actual upper bound, then it is injective. Mm-hmm. All right, so part 3 is from part 1, which means part 1 is super important. We learned the pattern of how H translates to a nested G function call. So the answer is as follows. So in this case, we have a very specific V, a value that is generated by the applying H to a particular no terminated string, which is str. And I want you to figure out what are the 4 elements in str. In other words, this is implying that there are 3 non-null characters and there's 1 null character, or at the most, there are 3 non-null characters. So basically, what we do is we just apply the G inverse function. The first time you apply the G inverse function, whatever is the first element of the 2 tuple is the first character of str. And then the second number is applied, you reapply G inverse to the second number over here. It breaks it into 7 and 15. So this is now 7. And then you apply to G inverse to 15, which then gives you 5 and 0. The 5 is the last character that is not a null terminator, and then the very last one is the null terminator. So basically, you have to apply G inverse, okay, multiple times, pick out the first item to be the character, and then the second item you apply G inverse again, as long as it is not 0. So is that kind of okay or not? Mm-hmm. 268. This one? You apply G inverse. Yep. Mm-hmm. Because G inverse converts a natural number back into a 2 tuple, and then each item in the 2 tuple is guaranteed to be a natural number. All right. So did someone, without a calculator, just kind of talk about the approach of doing this? Because that by itself is worth, I would say 3 out of 4 points as well. What?
Remember that? Well, I didn't remember how to like how W is defined, and I had only written it down in terms of W.
Oh.
And then I just said I don't have time to rederive W.
Oh, okay. Did you show any steps?
Yeah, okay.
Okay. All right. So question number 2, 3, and 4 are similar. So in this case, everything that I corrected, is in a box. The red portion is supposed to be changed. That's the wrong part. And then the part that is not in red is the new value. So in one case, there's a y, there's no y, there's only x. And then the other one, the other 2 corrections is there's an and that should be, no, I take it back. The implication should be an and. And then the last one is the negation, neg, because I use single backslash n, eg, and the tool that I'm using to convert into this format, ate the backslash n as if it is a line feed. So all we can see is eg something. So that's kind of the correction here. All right, so let's take a look at number 2. So number 2, the first question is asking which relation property is confirmed about R over X if C0Rx has a cardinality of 0. In other words, I'm really asking C0 is showing us counterexamples of what? Okay, and the correct answer is symmetric or symmetry. So let's take a look at why that is the case. Okay, so we look at all the E from X, we look at all the F for each E from X, for each F from X. So E and F are basically the only requirement for E and F is that they are elements from X. But we're looking at all the possible ways to pair E and F. Yes? Hmm?
Like in the set C1, is it not EG or is it EFG?
It's EFG. That's actually correct. So in this particular question, I'm asking about the 3 tuple EFG. So if you're only looking at EG, then you get partial credit. I mean, a good portion of it, but still partial credit because it's asking for, it's potentially you can have the same EG, but a different F in between. So it depends on how the how R is set up. You can potentially have two, well, okay, not when X only has three elements, but when X has more elements, then you can potentially have the same E and the same G, but in between, you can have two different Fs and therefore generating two different three tuples. In this case, it is not possible because all we have are three elements. So with three elements, if E is locked, well, let's see. It can still happen. Okay, I correct myself. It can still happen because E and G can be the same. Okay, let me show you why it can happen. Okay, it's kind of important to talk about why it can happen. So today I'm trying this kind of fancy thing, because I can write here. Okay, so we'll just say that X is, all right. Okay, there we go. Just a delay. Okay, 0, 1, and 2, just like in the question. And then in this case, R is going to be, let's say 0, 1, 1, 0, and then 0, 2, and then 2, 0. Okay, so given this is how X and R are defined, we're looking for two quote-unquote counterexamples to show that this particular R is not transitive. Okay, so the question is, how can we show that? Well, we can see that, okay, this one actually has many examples of why it is not transitive. So the answer to this one is going to be, the set that contains 0, 0. Oh, okay. I said one thing and then I wrote down something else. Okay, 0, 1, 0 as a three tuple, because 0, 1 is here, 1, 0 is here, but 0, 0 is not there. Okay, so that's one of the three tuples. But then we also can use 0, 2, 0 as a counterexample, because 0, 2 is here, 2, 0 is not here. So 0, 2, 0 is a different three tuples to basically say, hey, 0, 0 is supposed to be here in order to be transitive, but there are two, it's missing, okay? And obviously there's also the other ones, 1, 0, 1 is 1, and then 2, 0, 2 is also 1. So the correct answer would consist of these three tuples if X and R are defined in this way. Is that okay? What about 2, 1, 2? Why is 2, 1, 2 not here? Well, because 2, 1 is not here, 1, 2 is not here, it's not in R either. So that's why 2, 1, 2 is not going to be one of the three tuples. Is that okay? All right. So once again, depending on how you answer the question, even if you don't get all of the elements, you can still get partial credit. Question? No? Okay. All right. So now we can return to the original question and resize that. There we go. All right. So in this particular case, 0, 1, 2 is an answer because 0, 1 is present, 1, 2 is also present, but 0, 2 is missing. So that's why 0, 1, 2 is one answer. 1, 2, 0 is also an answer because 1, 2 is here, 2, 0 is here, but 1, 0 is not here. So that's why it has three tuples as the answer of C1. C0, on the other hand, is looking for symmetry. So this particular format of ERF and not FRE, or not ERF and FRE, is, I would say, classic exclusive OR, okay? Because this is one way to say ERF exclusive OR with FRE, which is also basically saying one but not the other, okay? So if you have one but not the other, that means oh, it is not going to be symmetric. Because in order for a relation to be symmetric, either both are missing, that's good, or both are present. So if one is here but the other one is not here, then it is not symmetric. So that's why part one of the answer is symmetry, part two is transitive, and then part three has this particular set, has this particular set here because 0, 1 is present, but 1, 0 is not present. So that's why 0, 1 and 1, 0 are both in the answer because the expression that is inside these parentheses is by itself, quote unquote, symmetric. You can flip E and F and it will give you the same answer. Yep.
If E or F is not there,
Mm-hmm.
it means that it is symmetric.
Okay, so you can, but there's an or.
It is or, but the next of the or should be correct.
Okay, give me some concrete value. What E and what F are we looking at?
Just for the description, just for the part one, I thought.
Mm-hmm. Just for this one,
Yes.
and
I was thinking it looked more comparable than symmetric.
oh no, it's not comparable. Okay, so I can have something that is. Let me see here. I can have something comparable is the other one. You know, there's another one that is comparable, but this one is not about comparable. Because this one, in order for EF as a two tuple to be in C0, um, it means this OR has to be true, which means exactly one of the two has to be here, but not both. Okay, so that means an element with not relating to itself is not going to be caught because if EF are the same, then both of these will have to be false, which means the OR has to be false, right? Mm-hmm. Any other questions? Okay. So are we good with number two, question number two? Okay, all right. Moving on to question number three. So for question number three, the only correction is once again the y should be an x. And symmetry is the same as number one. And then this one has a different C1. And in this case, the C1 has an expression of um, right here. This is the actual expression. ERF and FRE and E and F are not the same. In other words, I'm looking for a case where ERF is true, which means EF is in the relation. FE is also in the relation, but F does not equal to F. So that would make it not anti-symmetric because anti-symmetric means whenever we have ERF and FRE, E and F must be the same. This is looking for exactly the opposite. So that's why it is, if C0 returns an empty set, then the R relation is anti-symmetric. Is that okay? And in this case, it returns an empty set because the R, the relation that we have here is actually anti-symmetric. Okay, let's think about why it is anti-symmetric. What needs to happen in order for a relation R to be not anti-symmetric? Well, in this case, we have 2, 1. We better have 1, 2 to also be in the relation in order for the relation to be not anti-symmetric. Having just one is not a problem. Having none is also not a problem. Having both is the problem. Is that okay? All right. So the ordering of these particular, combination may not be the same for you. Basically, I have a program to generate all the combination and permutations. So that's why I teach this stuff, because I'm actually using it. All right, so let's look at question number 4. Question number 4 has a different C0 that we haven't seen before. So this one, actually the other one is also new. Okay, so both C1 and C0 are new. So let's take a look at C0 first. This is the one where the implication should be changed to an and. And I looked at I looked at a few of your submissions, and I think of all the ones that I looked at, you guys made a correct correction also. So that's good to know. So in this case, what does it mean? E and F are the same, which means, well, they're the same. And EF is not, there's a negation here, EF is not in R. So that means EE is not in R. So that has to do with whether it is reflexive or not. But the result is still needs to be a tuple or two tuple. So in that case, it means the two tuple, both items of the two tuple returned by C0, they need to be the same. So in this case, 0, 0 is missing, 1, 1 is also missing. So that means the answer is 0, 0 as a two tuple as an element, 1, 1 also as a two tuple as an element. So with this one, I did, okay, I admit, I did, make it look a little bit more confusing, because I know what most people are looking for. Okay, they say if there's only one universal quantifier involving only one variable, it is reflexive. So I took that away. It's like, nope, this time we have E and F. I just have to say that when E and F are the same, then that particular two tuple is missing. All right, and then C1 has this expression here. So this is the one where EG is supposed to be the negation symbol. So let's see what this one means, okay? So this one has an implication. The implication says, not ERF implies FRE. So if you apply Boolean algebra, you can turn that into, oh, okay, it means the same thing as ERF or FRE, because when you have an implication, it is the same as an or, but you have to remember to negate the left-hand side first, okay? So now we basically have an or, but we also have an extra negation to negate the or, which means with the or itself, it is comparable. But then with the extra negation on the outside, it means not comparable. So we are basically looking for counterexamples that makes R not comparable. And in this case, there are many things that are missing that makes it not comparable. So between 0, 1 and 1, 0, it is not comparable because, let me see. Am I generating the wrong outcome here? Okay, let me plug in the values. So if I plug in 0, 1, then we have 0, 1, 0R1 or 1R0. So that is true. But when we look at the negation, that is false. I think I forgot to put a negation on the whole thing. Okay, so this is the complement of what it is supposed to be. Darn it. Okay, I can fix the code and make it generate the right solution. Okay, so don't trust this one. If it is the answer of the comparable, it is not correct. I haven't really distributed the key to the whole class yet, so I can fix the script and have it to generate the correct answers, because I missed that one negation. Does anyone want to know what kind of code that I use to generate the solution? No? Yes? Okay, there are some yes and there are some no's. Okay, well, I'll show you guys a little bit. Okay. This is 440, and let me see. 1249 x2 q1 gen. And I'm looking for relation not comparable or connexive. Okay, there we go. So this is the function that I used in this particular case. Um, and what I did was I forgot about the outer negation. So I'm supposed to have one negation to negate the entire thing, and I forgot to specify that. So now that the script is corrected, let's go ahead and run it. Okay, so this particular script, generates all the examples, for this class of question, and then this particular script packages all the questions together into the actual question with all the keys automatically generated. So now if I go back here and refresh, that will fix it. So these are the actual, this is the correct answer. Okay, so let's check whether that is correct or not. Okay. 0 does not relate to 0 in R, so it's missing. So that means it is a counterexample of why R is not comparable. 0, 2, and 2, 0 are both missing because you can see from here, 0 and 2 are not related in any way. Okay, and then 1, 1 is also missing because 1 does not relate to itself. Okay, we have 1 relating to 0, we have 1 relating to 2 twice, but 1 does not relate to 1. So 1, 1 is also missing, making the relation not comparable. Are we doing okay so far? Okay. So question number 5 does not have a key that is automatically generated because I actually have to read your steps and see if it is correct. Okay, so this is going to be the one that will take me the longest to grade. And then question 6 is also going to take some time because this is the automatically generated one, which is very mechanical, and it's probably a lot longer than it has to be. Okay, so I'm suspecting most of you, got this figured out, in much fewer steps. Sorry. All right. But this is the mechanical way to do it. Okay, basically I just exhaustively do everything until I get to the false. All right. So are there any questions about exam 2? Yes.
Are there multiple like variations of question 6?
Yes.
Okay. Are all of them solvable?
Yes. Yeah. So after the class, I can look up yours and I can basically show why it is doable, why it's solvable. But yes, they're all solvable. Yep. Because my script would actually evaluate the original one and make sure it's solvable, in order to use it in the question. Yep. All right. So are there any questions about exam 2? The good news about exam 2 or this class in general, unlike CISP 310, is for this class, relations, we're done. Okay, the final exam is not going to have relations. Okay, in terms of the G function, from LF, the final exam is not going to have that either. In terms of propositional logic questions, like the ones that we just looked at, the final exam won't have those either. So from that perspective, this class doesn't have the same depth like the chain of connections, of all the topics like CISP 310 does, or at least the way that I teach CISP 310. So for this class, we are pretty much done with propositional logic, we're done with relation, we're done with Aleph No. Okay, so the final exam is going to only have topics that we are not including in X1 or exam 1 or exam 2. So that would be probabilities, discrete probability, the two graph algorithms. One is called A star, The other one is called Dijkstra's algorithm, and potentially some questions on predicate calculus. I haven't quite decided yet. So that's that. So do we have any questions about exam 2 before we move on? Yep.
I know you grade on like the 0 through 4 scale.
Mm-hmm.
Do like 3.5 or at least.
Yeah, I do 3.5 sometimes. It kind of depends on, what question and how the answer is close to the perfect answer.
If I did like the EG instead of EFG, that first question.
I can't answer the question right away, but I'll tell you at least the 3. It will be at least the 3, but there are, as I illustrated earlier, there are possible cases where there can be 3 tuples, but they correspond to the same 2 tuple. So that's the real trick to the 3 tuple method. It would increase the number of elements in the outcome. Hmm?
I think this is my exam.
Oh, this is yours? Okay. All right. Any other questions about exam 2? So I'm going to do exactly the same thing. I will find the closest I can do with a 90 percentile or the score at the 90 percentile, and then rescale everybody so that the 90 percentile score becomes the new 100%. I cannot tell you how the grade is distributing because I haven't finished grading this particular class yet. I've graded a few, but not the entire class at this point. But so far, I have not seen a 4/4, so so that's good news for the rest of the class. With CISP 310, I graded the Monday Wednesday class, and there was like the first one that I graded was a 4/4. So, but since I'm looking at the third highest score in that class, it is entirely possible that the second highest score is a 2/4, and the third highest score is a 1/4. So everybody gets like a 400% multiplier to the original score. Well, that didn't actually happen, but it's possible. All right. So let's go back to, so the next thing I guess we should do is to revisit these questions that I gave you guys before exam 2. So we'll take a look at the TAC GPT problem first. Okay, so how many people still remember this question? All right, let's go ahead and just read this question and figure out how to solve this problem. All right, so the key here is every box of Urbies, there are 100 toys in every box. The quality control process will randomly choose 8 of the 100 Urbies and test them and see whether they are operating correctly or not. If at least 3 out of the 8 being sampled are behaving unusually, then the company will launch an investigation to basically examine the entire box and try to figure out why they're behaving unusually. So is that part understood? Okay, you have a box that has 100 things, of which we choose 8 of those for spot checking. If at least 3 of the 8 that we choose to spot check behave unexpectedly, then we say, okay, now we have to launch an investigation. Is that okay? All right. So in this case, I am trying to install TAC GPT illegally on these Urbies, and I am going to not be safe, because the safest way to do this is to install only up to 3 Urbies. Install TAC GPT on no more than 3 Urbies. So this way, I'm always below the detection limit. But I want to spread TAC GPT as fast as possible. So I decided to take a risk and install TAC GPT on 10 out of every 100 Urbies in a box. So the question now is, what are the chances that I will be caught in this, in the QC process? All right. So how do we answer this question? First of all, Is it a permutation problem or is it a, well, okay. First of all, the choices or the outcome set between trials, are they going to be the same? Because the whole thing is supposed to be quote unquote an experiment, okay? So what kind of experiment are we looking at? Imagine a bag instead of a box. In this huge bag, you have 100 herbies. And what are we doing to the herbies? We choose 8 of those, right? We take 8 herbies out of the bag and say, hey, you guys are the ones being sampled, okay? So the question is ordering important in this case? Nope. It's any 8 out of the 100. So ordering is not important. We are looking at a combination kind of problem. So when you think about combination where ordering is not important, the first thing you should think about is lotto, okay? Because we solved that problem already. We know how to solve all the probability related to lotto. So now you have to apply the same thing and ask, okay, so what do we do about this case? Okay, so I'll write it down, okay? So I will, is handwriting better or do you want me to just kind of write it in a regular text editor? Any preference, handwriting? Okay, all right. So if handwriting is preferred, I'm gonna scroll this one off the screen, like so. And then I can do it on this side too. Okay, there we go. So we have, how many ways can we choose 8 samples out of 100? Okay, well, that's just your 100 choose 8. Okay, so most of you probably figure out, okay, 100 choose 8 is probably an important number. It is an important number, but what is it? Okay, we got a few things, so in order to calculate the probability, we are basically looking at the ratio between the event set, which are consisting of all the things that we are interested in, versus the outcome of the entire experiment, or the number of outcomes of the entire experiment. So what is this one? Is this specific to the event that we are interested in, which means tech got caught for installing tech and GPT in the herbies? Or do you think this has to do with, it's just the number of ways that we can choose 8 out of 100? There are this many ways of creating the samples to begin with. Okay, so that means this is the cardinality of omega. Okay, the cardinality of omega, in this case, omega means the outcome set for the entire experiment. The experiment consists of 6 trials. For each trial, I'm taking 1 herbie out of the bag, starting with 100 to begin with. Is that okay? All right. So this is not unlike the number of lotto tickets that we have to deal with. Okay, so with lotto tickets, the most important part is, I think it's what, how many numbers do we choose from? 69, I think. So 69 choose 5 is the total number of lotto tickets, not accounting for the Powerball number, okay, because the Powerball number is completely separate from those 5 numbers. Okay, so now we have to say, okay, what about the event set? Okay, what makes it to the event set? So we'll say X is an element of the event set if and only if what? At least 3 out of 8, okay? So we say at least 3 of X have TAC GPT installed. Okay. Is that okay so far? Because this is E is representing a set of all the possible outcome, which means E is a subset of omega. Okay, so now the question is, well, what qualifies, a particular sample of 8 to make it into the event set? Well, the qualifier is tech got caught because of that sample. So how did I get caught? Well, guess what? At least three out of the 8 in that sample has tech GPT installed. Okay, so we'll just say that, okay, so let's just say that, it's a particular number because, that's what we're interested in. So let's just say that we are now interested in I out of 8 in the sample as tag GPT installed. In other words, I am parameterizing, okay, because, we need to look for 3, 4, 5, 6, 7, and 8, okay? So I need to iterate through the I, starting with 3, ending with 8. Okay, so how do we figure this out? Okay, okay, very good. So to get the I, okay, to get to the I, the I can only be chosen from how many? Out of the entire box, okay, from the original problem description, out of the entire box, how many have tech GPT installed? 10, okay, according to the question, there are 10, okay? So out of the 10, I have to choose I of them. Is that okay? So that means we are looking at 10 choose I, okay? This is the number, this is the combination or the number of combination that will give me, the total number of ways of installing, of choosing out of 10 tech GPT hacked, Urbies, I'm choosing 8 of them. Is that okay? What about the other? Okay, because remember, each sample has 8 items in it. So what about the other items, which would be 8 minus I? So for the rest of the sample, where do I choose them from? Well, 10 has TAC-GPT installed, which means how many do not have TAC-GPT installed? 90, okay, 100 minus 10. So I'm going to write exactly that, okay, because I want to make sure that you guys see the relation between the 10 and the 90. So this is the cardinality of E. This is the cardinality of E. So the ratio between the cardinality of E and the cardinality of omega is the probability. Wait, there's a little bit more to this, okay? So this is, parameterized using I. So that means, what I actually need to do is to do the sigma, because there are multiple, subsets of the event that I need to do. So this one is just having exactly, okay? This is the number of exactly I of the 8 samples have tag GPT installed, okay? But the question is not asking about exactly 3 or exactly 4. It is asking about at least 3, okay? Because according to the question, let me go back to the question itself. The question says, if at least 3 of the 8 behave unusually, and having tag GPT installed definitely make it, behave unusually. So that means in this case, we have to loop I through from 3 all the way to 8. So that means, we have to look at the sigma notation. So let me move this up a little bit. Okay. So now we are looking at sigma I starting from 3 going all the way to 8. 10 choose I times 100 minus 10, which is just 90, choose 8 minus I. So this becomes the actual event set, or the cardinality of the actual event set here. So we take the cardinality of the event set divided by the cardinality of omega. This becomes the actual probability. Does anyone want to know exactly the chances of me getting caught? Okay. So the best way to do this is to use a spreadsheet. So I'm going to go to the share folder, create a new spreadsheet for today using today's date. So that makes it easier for you guys to find it. And if you have a computer or a mobile device, you can actually see it being constructed as we talk about it. So this is 2024, 11, 18. All right. So we are looking, this is I, okay? So I goes from 3 to 8. So this is 1 plus the one before. So we got 3, 4, 5, 6, 7, 8, right? So, and now we are looking at the actual number, okay? So we are looking at the cardinality. So this is going to be combin 10 choose the 3 times combin 90 choose 8 minus the 3. Okay, so we extend it down like this. But okay, so now we have a summation. Okay, and Google is really smart. It kind of figures out what I want to sum over, and this is the total number. Okay, but this is the total is really just the cardinality of the event set. So the next thing we need to do is to look at the cardinality of omega. So the cardinality of omega, which we talked about already, is really just 100 choose 8, because that's how we choose 8 to sample. So that's this number. And now the probability is just the ratio between these two. So that would be this number divided by this number here. And so the chance is about 3.14%. But that's only for each box of 100 Urbies. So that means, once they have shipped, what, about 33 boxes, almost for sure I'll be caught. Yep.
What is the safest way to do this? Is to like 2 of them per box? So
Yep. Up to 2. Yep. Well, okay. So even that is not completely sure, because there can be also bugs and hardware problems with Urbies that is causing a non-tech GPT Urbie to behave unusually. So I can be caught because of that. But assuming the manufacturing process is 100%, then only the ones that have my malware installed will get caught. But you're correct. If assuming there's no hardware problem or any other way for Urbies to behave unusually, then as long as I don't install 3 or more, then I'll always be safe. Yep, that is correct. All right. So, any questions about this? Yep.
I guess I'm kind of confused, not so much about this part, just the last part you mentioned about shipping out roughly 30 boxes, almost guaranteed to be bought.
Oh, that's just me looking.
Like a 3% chance for each box, though, so doesn't
Yeah.
it?
So cumulatively over 33 boxes, then I run out of luck. Now, is it sure that after 33 boxes I'll be caught for sure? No, that is not true. But you can actually calculate that probability as well. Is how unlikely that I won't be caught, after 33 boxes. Because that would just be looking at not getting caught. This is the chances of getting caught. So you're looking at, if you look at the chances of not getting caught, is 1 minus this. And then to do it, 100 times or 30 times, that would be the probability of getting away with shipping 33 boxes and not get caught. So let's do that. Okay, let's figure out what that number is. So this is the probability of getting caught. So now the probability of not getting caught, excuse my notation here, okay, it's just kind of handy to use the C notation. So this is the probability of not getting caught for each box. So if we look at 33 boxes, okay, that becomes the power of this number raised to 33, and there's a 35% chance that I won't be caught after shipping 33 boxes. So adding the probability is not the right way to do it. This is the right way to figure out, what are my chances of still being able to get away after shipping 33 boxes of these Furbies. Yes, because Furby is trademarked. Are we doing okay so far? Okay. All right. So are we ready to move on to the next question? Okay. So we're going to move on to the next announcement, which has to do with potions or deadly potions. There are 10 potions in a room, okay? So imagine this as an adventure game, okay? So you are playing a character, you go into a room, and then you have to consume 10 potions in whatever order you choose. But 3 of these potions are poisonous if they are consumed consecutively in whatever order, okay? So the question is, what are the chances of fatality if you drink all 10 potions, but doing so randomly? So how do you analyze this problem? Yes. Yes. Yep. So let's say potion A, B, and C out of the 10 potions are the 3 that can be potentially deadly. So that means you have to be consuming A, B, C consecutively. So if you consume A and then some other potion and then a B and then C, not a problem. Okay. But as long as these 3 are consumed consecutively, ABC will kill you, ACB will kill you, BAC will kill you, and so on. Okay. So the ordering within these 3 is not important. Okay. Are we good so far? Um, as long as you consume potions A, B, and C, consecutively, it doesn't matter which one you consume first and then second and then third.
Right, but you still care about it, when you, for example, when you were doing the previous lectures, right, you were talking about it matters the order.
Mm-hmm.
In this case, for this one, should matter the order.
Yes, the ordering is actually important in this case, because in this particular problem, what is our omega? What is the outcome set of consuming 10 potions in a room? And ordering is important because how do I otherwise know whether I consume those 3 consecutively or not? So ordering is important because if I interleave at least one of the non-lethal potion between these 3, I'll be fine. So that means ordering is important. Okay, when we look at omega. Okay, so let's go back to yeah.
Partially though, because you can also be like, the order could be if you drink it from 1 to 3, or if you drink it from 7 to 10.
That part does not matter because if you drink A, B, and C last versus drinking A, B, and C first, you're still dead. Okay, so the question now is how do we analyze this problem and how do we solve it? Okay, so we'll go ahead and scroll this up. At the end of the day, if you guys want me to give you like access to this whiteboard, I can do so, but I don't want to do it during the class. I just want to kind of do it at the end. All right, so let's go check out how we can solve this problem. Okay, so omega, okay, it's still trying to make a connection. Okay, Let me refresh on this side. Oh, I still have it. It's just it has to restart the whole Teams app. There we go. And I want to scroll this up. Okay. All right. So this is where you can see it. All right. So we want to look at the number of ways of choosing 10 potions out of 10 potions. But this time ordering is important. Okay. So that means we cannot be using combination. We're not counting combination. We're counting permutations. Okay. So this number is now using p, and we are choosing 10 out of 10. And if you work out the math, it is the same as 10 factorial. Is that okay? Because out of the 10 potions, any one can be the first one. But once you have chosen the first one, you only got 9 left to be the second potion that you want to drink. And then once you have chosen the first 2, then you only got 8 to choose from for your third potion, and so on. Okay, so that's 10 factorial. So that's omega. The complexity of this question has to do with the event set. Okay, how do we count the number of event sets? Okay, so there's a trick to it. The trick to this thing is to treat the 3 potions, or the 3 deadly potions as one single unit. Because all we want to know is the probability of dying. Okay, so all the chances of not dying is not really of importance to me. So that means of all the things in the event set, they all have A, B, C grouped together contiguously. Is that okay? So for the time being, we just say, well, we'll just put a rubber band around those 3 potions that are deadly, and we'll just say we'd be looking at, okay, so if we group these 3 potions together as one thing, okay, and how many permutations are we looking at with all the other potions interleaved any way they want, but they cannot be interleaved with these 3. Is that okay? So how many other potions do we have? 7 plus the group of 3. So we have 8 things that we have to kind of look at. So now we say there are 8 factorial ways to choose how to drink and die, considering the 3 deadly potions, potions as one. Is that okay? In other words, it is as if somebody just pre-mix the 3 deadly potion into its own little bottle, okay, and say, okay, instead of the 3 individual potions, I just put this pre-mixed deadly potion into the mix and go like, okay, how many ways can you die? Because you're guaranteed to die this time. Because out of the 8 remaining potions, 1 is always deadly, and you're gonna drink all 8. Is that okay? So the answer to this particular question, okay, is 8 factorial. Okay, I answered the question already. But that's not the answer, okay? Because of the 1 potion that is deadly here, you remember the rubber band, or you're pre-mixing the 3 deadly potions. How I mix the 3 deadly potions together, the ordering is actually important, okay? Because in other words, if I consume, because I'm trying to treat ABC together as one single unit, but ABC, ACB, BAC, BCA, CAB, and CBA these are the suborders of how I can pre-mix the deadly potion of the 8. So there are 6 ways to do it. So that means the 8 factorial needs to be multiplied by 3 factorial in order to be the size or the cardinality of my event set. Yes? Oh, sorry. There we go. So now we have the cardinality of the event set. We have the cardinality of the omega set. So now the probability in this case is this divided by this, which we know is 8 factorial times 3 factorial divided by 10 factorial. So that gives me the chances of me dying if I were to drink the 10 potions in random order. Yes?
You said that the order matters, so you're saying there's a possible that drinking A, C, and B will still die? I thought it was needed to be sequential.
They need to be sequential, but in any particular order. In other words, A, B, and C, they only have to be consumed consecutively, but you can choose any one of these 6 ways to die. Yes.
Oh, okay. I thought it was no matter what, it was going to be A, B, C,
Nope.
A, C, B.
Yep. But this group can interleave, can be, this group has to stay together, but how this group relates to the other 7 potions is free. So we can have 7 potions before this, 3 before this, 4 after this, and between those 3 before, any order is fine. Okay, the 4 after, also anything is fine. But instead of analyzing it that way, we just say, okay, let's group these 3 into one single unit. Then we have 8 units, the 7 non-deadly potions and the 3 deadly ones that are grouped together. So we have 8 groups. So now we look at 8 factorial to figure out how many ways can we order these 8 groups. But within the group that is deadly, we have 6 ways to arrange it. So that's why we have to multiply 3 factorial to the 8 factorial. So does anyone want to look at the actual number? How likely somebody is going to die in this particular room with 10 potions? Let's check it out. So is that the correct one? Yep. Okay. So I'll put it over here. Okay. So we have the cardinality of omega. So the way you can do this is you can use factorial, which is FACT, I think. Yep, so FACT. But you can also use permutation because 10 out of 10 is basically the same as 10 factorial. So now we look at the cardinality of E, which is permutation of 3 choose 3 times the permutation of 8 choose 8. Not 7, but 8. And now we look at the ratio, okay, the probability of dying. So that would be this number divided by this number here. So it's a 6.7-ish kind of percent chance of dying. Is that okay? All right, so let's just say that you do not agree with this, okay? You think something is wrong with this calculation. How do you validate or verify that these numbers are correct? Hmm? That's going to take a while. And the first time you die, you cannot drink, you cannot do the experiment any further. Okay, so how do you check these things? Exactly. You can use a program to do this. Okay, so the way you do this, which is not what I recommend, it's doable at this point. Okay, so 10 factorial is not too bad. It is still doable. Is to basically make a string. Okay, you can use names, you can use numbers. I would just use numbers like 0 to 9. Okay, you generate all the permutations of 0 to 9. Okay, and then you just say, okay, 0, 1, 2 are the ones that are deadly. And then you use a filter, okay, to look for 0, 1, 2 in whatever order but staying together. Okay, So you can basically use a program to empirically do all the counting, okay? So how many did I generate? Okay, 10 factorial. And how many of those turn out to be deadly after the filtering? Well, that's kind of up to you to kind of implement the program and do all the counting. But you can do this. Now, is that the best way to do probability, discrete probability? No. But is it a good way to kind of practice this whole thing? I would say yes, okay? And how would you do that to kind of make this program? Chat. Well, let's go ahead and try that out. Okay, we have 5 minutes. Okay, let's see whether ChatGPT can answer this question quickly. So we go to ChatGPT, and I signed in already, so that's good. Just strictly copy and paste. All right, so we got a 10 factorial, and it uses the same method that I was using. Yep, got to do the same answer. Now, how should you feel about this? No, it did not. That's what ChatGPT is supposed to do. It just gives you the answer with explanation along the way. So you can write a program, okay? So if you are to write a program to do it the empirical way, how would you do it? Okay, first of all, which programming language are you going to choose? You choose whatever programming language that already has modules that can deal with permutations, like actually generating permutations. JavaScript can do it because I use it in the program to generate all the exam questions. Okay, I suspect Python also can do it. Okay, so you choose a programming language where you don't have to do all the heavy lifting. It's already done for you. Okay, and then what you do is you generate a huge, gigantic array, with all the permutations, and then you write your own code to test to see whether 0 and 2 are consecutive. But it can be 2, 1, 0, 1, 2, 0, and whatever. So that part is up to you to decide, okay, how you want to do that. So you can write a program like that, okay? And I would say JavaScript is probably the to me, it's the easiest way to do it because I'm familiar with JavaScript. If you're familiar with Python, yeah, use Python. I'm not sure whether C++ has standardized libraries to deal with permutations or combinatorics in general. I suspect it does, but you might have to download and install those libraries before you can make use of those. Is that okay so far? Okay. So now that we are here, we still got 2 more minutes. So I'm going to ask ChatGPT another question, which is the first one, the TAC GPT question. So let's see whether it gets that one right or not. So we'll go back to this one. And the best part about these kind of questions is they are really just word questions. There's no math symbols whatsoever in the question itself. So that means using ChatGPT is strictly just copy and paste. Yep, it found the approach. I can see that because of the pattern here. So it's figuring out, having 1 getting caught in the sample, 2 in the sample getting caught, and now it's generalizing to x is greater than or equal to 3. And it ends up at 28.04%. That is not correct. Okay, wait, did I? That is not correct. All right. So it's P1 minus Px equals to 0. No, none of the 8 has a problem. 1 of the 8 has a problem, and 2 of the 8 has a problem. The rest are all problematic. So did I make a mistake? Okay, so let's double check. So this is 3. Okay. So we want 3 out of the 10 that has TechGPT, and then 8 minus 3, which is 5 out of the 90 that does not have TechGPT. So so the 8 is the same as a 2. Nope, it's not. Okay, so let's check ChatGPT's math. Okay, so when it's 1, then we are choosing 1 out of the 10, and then the rest 7 is out of the 90. So that's 33.4%, 15%. Did I do the omega incorrectly? It is combin 108. What about ChatGPT's answer? It is also divided by 100, choose 8. Huh. All right, well, huh? No, this is just for 90 choose 6. Shouldn't the denominator be what? It's 84 factorial if it is permutation. But because we're looking at combination, this is correct. So okay, fine. I'll figure out why there's a discrepancy. All right, so I'll see you guys on Wednesday. So on Wednesday, we are going to continue with the discussion of time complexity. So we'll resume the topic flow. All right, so I'll do some debugging here. Okay, what did I do wrong? Oh, I know. Wait, no, that's not it. B2 to B7, that is correct. Probably. I'm hoping by Wednesday.
Oh, okay.
Yeah.
Hoping
Well, I can always give you the key and also your scanned exam.
Oh, okay.
So this way you can grade yourself.
Oh, yeah, that's true. A lot of it I don't remember what I put. So I don't know. I don't know if I just left my brain already.
I see. Okay. Yeah, I can send you back your exam. That's easy because I have everything scanned already. I already have the script to quote unquote send the scanned copy back to you. But since I haven't really gone through the whole thing to figure out which exam version you have, so I cannot send you the key until I grade it, because that's when I actually put in the key so that I can compare your answer with the key. Well, I mean, I can do the first step first. I mean, that I can do like almost right away. Mm-hmm. All right. So I still have a mystery to solve here.
I actually tried doing it with ChatGPT and it didn't match. That's I'm like having a hard time reconciling the two values.
Yeah, but I want to figure out why they're not reconciling.
Yeah.
Yep. So I'm gonna do I'll do the first two too. So.
I have a question
Mm-hmm.
about the first problem we did with the urbans.
Mm-hmm.
It's on the whiteboard that we're looking at.
Oh, give me a second here, because I'm just looking at this. Okay, so now I want to add this number to this number. This is definitely a lot bigger than that. So I think ChatGPT got this one wrong. between these two, that's almost the entire thing here. So between the 0 and 1, that's almost the entire thing. And according to ChatGPT, between the 0 and the 1, it only accounts for 1/2 of it. So the math is definitely wrong here. So it's either me or ChatGPT.
Is there still hope for us?
Because this number doesn't match what ChatGPT gave me. So D10 is indeed the 0. I'm just aligning the rows here. Yeah, okay, that's 0. And according to ChatGPT, this thing, and it's divided by, okay, so it did all the division already. Fine. But it's still only 0.235%, as opposed to this one, it's already 1/2 of almost all the cases. Because if I do a division between this and omega, that's like 0.41. So something is not right. I think my math is still correct. Because just roughly, they seem to make sense, right? Between these three, the ones that we're excluding. Oh, wait. Right, because this number has to be an absolute number. So that means I need to put a $sign on the row number. There we go. Okay, now we can do that. So between these three, that's like what, 90 something percent already? So the math seems to work out, they seem to add up okay on my end. All right, so I'm going to pinpoint that problem later. I'll try to answer your question first. Go ahead.
You scroll up a little bit.
Mm-hmm.
A little more. It was about the cardinality of E. I think there were two different places where you like wrote what it was, but they were different.
That's not what I want to do. Undo.
I think it is found out. So E is the cardinality that, or the cardinality of E is that exactly I of the 8 samples have IQT, but then summation is that exactly.
Oh, this part there should not be equal to cardinality of E. This one is correct. This is only for one case.
Okay.
But we have to add up these 6 cases here. So this is not correct. I mean,
Okay.
so strictly speaking, I should be erasing this part. Undo. Okay, come on, give me the eraser. There we go. It's just, all right. Get rid of that. There we go. So this is just one of the many cases where I need exactly I detected out of the 10 that have TAC-GPT installed.
Okay. That's how we do the summation.
Yep.
So that's like, okay.
Yep. Sense. Yeah, but the math somehow do not match up. And in this case, I think my math is correct because 10 versus 90, this is the ones that have the ones that have problems. So 8 minus this number would be the ones that do not have a problem. So when you add up these three, it's already 96%. So my number is adding up correctly.
Those are the odds that it doesn't have a problem.
Correct. And ChatGPT is giving me a whole different number.
I've noticed it has a hard time with like very large numbers. Maybe that's part of the reason why. I don't know why.
Overflowing like the largest integer, maybe.
If I wanted to see like I know we just saw my answer key, but like the scan copy.
Yeah, send me an email. Send me an email with your student ID. Just send it directly from your W ID account. Yeah, so that way I know that's you.
Okay. All right.
Yep. All right. Time to stop the recorder now.